YouTube, coming at you in a very joyous moment in my life, and wanted to share it with you and some of my science friends who are on this channel. And now I can finally talk about it. So I've been on this project for 5 years now. It's a research project, and anybody in sciences know that if you're doing something pretty cutting edge in science, that you don't really talk about it too much until you're published, because there's intellectual property issues with that, and then also just patents and stuff like that. So I've been working on this project that was just published. This is my manuscript, my first published manuscript, and it's about the research that I do with plants. So a lot of times I talk about science on this channel, but I'm really a plant scientist. That's my focus, and specifically plant microbiology. So, and plant ecophysiology. That's kind of where my crossroads hit. And the research that I do, I think, is pretty interesting, and it will eventually get out into the public mindset a little bit. So I study endophytes, and endophytes are bacteria that live in plants, kind of like we have gut flora. Plants have their own interior microbiome, and very little is known about what these bacteria do for plants. And so what the research in a nutshell that we did was we extracted bacteria from a wild growing black willow and poplar species, and then we run molecular genetics to identify the species, and then we isolate and characterize the species. So what kind of activity do they show? Do they show any capacity to acquire nutrients like dinitrogen fixation? Are they cytoropores? Do they make iron more available to plants? Do they help immunity? Do they help with water use efficiency? And there's a whole spectrum of plant support that various bacteria actually do for the plant. And it's really important for us to learn more about these endophytes, because for so long, research in agriculture has kind of treated plants as individuals. And just like humans, or any other animal for that matter, plants are a community of organisms. So they're microbes, and they're fungus, and viruses, and they're not an individual entity. Nothing alive in this world. We're all multicellular organisms. And agriculture and food production has been treating plants like individuals. So, you know, with heavy application of chemicals, with antibiotic runoff from industrial animal processing, and having those antibiotics get into the, into the fecal matter, and then they spray it on the crops, and then those antibiotics go up into the plant. We are, in fact, in industrial farming, really destroying plant microbiomes. And when we destroy plant microbiomes, we are destroying the natural support that these microbiomes give the plant. And the negative feedback cycle is it actually requires us to use more inputs, more chemical inputs, more plant support, more supporting them for their own immunity, protection against pathogens, etc., etc. We are just ostensibly taking things out of ecosystem dynamics and making everything very monoculture. And we know that that has really serious and deleterious effects. So that's the elevator talk in a nutshell. Now, what this particular manuscript was looking at is how these microbiomes help plants increase their water use efficiency. And this type of knowledge, as we're coming into an era of problems with irrigation, problems with drought, problems with increased global temperatures, and maladaptation of crops to changes in the climate, you have to consider that we use genetically replicated seeds to grow crops. So if you think about plants in a natural environment, when there's environment changes, they'll go through adaptations to what's happening regionally, if they can. Sometimes what's happening regionally happens so fast that they don't have the mechanisms to adapt. But when you're talking about agriculture, you're talking about plants that have exact genetic replication so that there is a predictable product outcome. And a predictable product outcome is what gives us homogenized product in the stores that people are like, I want my strawberry to look just like this. I want my tomato to look just like this. That doesn't happen in nature, and that doesn't happen in an ecosystem dynamic. So we're, as humans, forcing all of this artifice, and there's no adaptation. And that's a problem. So we can start to look at these microbiomes and understand how they impact plants, but then also start to use them to sort of re-enter ourselves into ecosystem dynamics. We can reintroduce microbiomes into plants and into agriculture settings that will help support the plant, that will help lessen water use, that will help to lessen chemical application, and that will help to lessen, medicines or protection against pathogens. So all of these are really important, and I don't want to let this video go too long and watch people glaze over. That's what happens normally when I start talking about plant science. But for anybody who's interested in sort of food production, sustainability, agriculture, and ecosystem dynamics, if you don't know about endophytes, start reading about it. It'll blow your mind. Go ahead and check out the paper that I published. I'll put the link down below. And if you have any questions about this publication, the science behind it, the research, put your comments below and we'll talk about it. I have another manuscript in the works. I can't talk about that one too much yet until it's published. But I think it'll be also very interesting. I haven't found any data sets showing what I found. So I'm excited to have that come up, and we'll talk more about that when it becomes available.